last transformation. So we have added ABC, amplitude, change in the period, phase shift. Today we are adding to that our last transformation, which is a vertical shift. Vertical shift is the same as we would have seen it from first semester, that it is outside of our function. It is an addition or subtraction outside of our function. It moves our graph up or down. Yes, it is moving our graph, but most importantly, it is moving our midline. Once you have moved the midline, you just base everything around that midline like the x-axis doesn't exist, like the numbering on the y-axis doesn't exist. It is all based off of that midline and where it has moved. Notice that it is added or subtracted. It is either no or outside of any parentheses that would be in the problem. That if it is a positive, it would move our graph up, and a negative will move our graph down, just like we would expect. So we're going to look at just a basic example of how to graph one of these with just that transformation taking place. So as we were to think through all of the different steps, our numbering on our axis is done for us. The very first thing we're going to do when we graph after the numbering on the axis is done is draw our midline. Our midline on this one is moved, as is the entire graph, moved up 2. So we are going to draw a dotted line, moved up 2. And once I have drawn that, I now have taken care of the 2, and we draw our cosine graph relative to that midline. Now has nothing to do with our x-axis. It's like this is our new x-axis. Your cosine curve was starting at 0, 1 because we weren't moving our midline. But it shouldn't be at 0, 1. It should be 1 above your midline. So since this is a cosine curve, it starts 1 above the midline, and our midline got moved up 2. Well, 1 above our midline would be starting right there. In this picture, up at 3. Once we have that first dot placed, we just follow our pattern. Right now we are off the midline, which means our next dot needs to be on the midline. So I would go from here to my midline, and then 1 below, so that my points are evenly spaced above and below my midline, like normal. Go back to my midline, 1 above, and we fill in that pattern back this direction as well. Midline below, midline above, nice smooth curve to connect my points. Any questions on that? So when we talk amplitude, and as we start changing our amplitude, remember that that is always going to be relative to this midline. So if I were to connect the distance from my midline up to either a max or a min, that should be the length of my amplitude. In this case, it wasn't changed, so it should be 1. Whether that is heading up or heading down, all of those amplitudes should be the same. And again, in this case, that would be a length of 1. 1 above, 1 below. Questions? All right, so adjusting our amplitude as we have a vertical shift. F of x equals 2 sine x minus 1, giving us a vertical shift of down 1 this time. So again, I'm not changing the numbering on this one at all. We're kind of taking that part of it out of this to start with. But I am changing where my midline is located. It is moved down 1, which means our entire graph is moved down 1. So I would draw my new midline, and now everything I do is relative to that line, not my x-axis. A sine curve starts on the midline. So since my midline got moved down 1, my sine curve gets started down 1. Normally I would go over 1, up 1, but because of our amplitude, we go up 2. Now here's what's a little different than what we saw before. Our amplitude used to match the number that I would graph to. But this is, again, the distance from the midline, not the actual number we graph to. So my distance of 2, up 1, 2 from my midline goes up to a positive 1 here, but is a distance of 2 from my midline because the midline got moved down 1. Back to my midline, down 2, back to my midline. Fill in backwards here, make sure we're alternating. So this one's above, then we would go below 2, back to my midline, up 2, back to my midline. Okay. Any questions on that addition of our transformation? Okay, so for the rest of the day, we're going to put it all together, and then the last half of today, we're going to talk about how to write equations, and we're going to get a little intro into writing equations, given either a picture or some information. Because we just finished our last transformation, I want to take a second and fill out what I would refer to as your trig summary sheet. So that's kind of that bonus note sheet that I gave you. Guys, this is a cheat sheet for you. So you write in words that make sense to you. Write as much or as little as you want. But I'm going to go through and talk through A, B, C, and D. Please understand that the letters A, B, C, and D are the first 4 questions on your DCA. Okay, so if you understand those 4, you at least get 4 points correct on there. Most people miss B if they're going to miss anything because of a little technicality in the wording. So just be careful on that. Okay, so starting at A, the mathematical word, and the word I would use as I describe it on my DCA because it's easy and efficient, is amplitude. What I'm also going to do is underneath that is describe, okay, well, what does that actually mean when I go to graph it? Because the word might not tell me. Yeah, it is my amplitude. That is my distance above or below the midline. Because it's a distance, it's always a positive number. Like I said, put that in your own words, whatever is going to make sense to you. But amplitude would be how I would describe that on my DCA. Next one, B. We want to say period, but remember they are related, they're not equal. So I can't say B equals the period, but I can say that it helps me figure it out. It determines would be an efficient way of saying that. It determines the period. Okay, and what I would want to remind myself on this is that B equals 2 pi divided by the period. Period equals 2 pi divided by B. That I use the period to, when I actually go to graph this, mark the 4th tick mark. Is actually what I use this for in my graph. C has a mathematical name called the phase shift. And again, that's the word I would use on our DCA because it's efficient and straight to the point. You could talk about how it shifts, is a horizontal shift or a movement right or left. Things that I want to remember for a phase shift is that it does just that. It's a horizontal shift. It moves my graph right or left. It'll move my graph if inside of there it looks like x minus some number. It'll move my graph left if inside of my parentheses it looks like x plus some number. Remember, when we identify C, it's always opposite of what is in the equation. Which you can write for yourself there if you want to. And D has a mathematical name called the vertical shift. It's probably the easiest way to describe that. Okay, and that one, easiest way to think about how that impacts my graph is it moves my midline up or down. If it's positive, my graph's going to move up. If it's negative, it's going to move down. And as long as I use my midline to graph the rest of the points, just moving the midline will fix that movement. The last one that I don't actually have up here is just a reminder that if we were to have a negative on the A, that's an ROX. And again, you can write as much or little as you want, but remember the difference between an ROX for a sine curve versus an ROX for a cosine curve. On a sine curve, an ROX means that when I put my second dot, it's going to go below my midline. On a cosine curve, my first dot is below midline. So then how do I attack all of this as I go to actually graph? There is an order that will help you. You kind of have to take into account everything as you're filling out your graph. But the very first thing that I would go to as I start graphing is B. This is the very first thing I would think about. And I would use B to number the x-axis. And once that's done, B has been taken care of. The second thing I would look at when I'm going to graph is D. And I would move my midline according to whatever D is. I would also use a combination, and you are welcome to write this wherever you want to if you want to, a combination of D and A, how far up or down my graph is, plus the amplitude compared to that, to number my y-axis. Like if my amplitude's 10, I'm not numbering by ones, right? If I have a vertical shift of 5, I'm probably not numbering by ones. We would number according to our vertical shift amplitude combo. Then after I've got my midline and all my numbering done, I would then start actually graphing my first dot using letter C. So the third thing I'm going to look at is letter C, and I use that to graph my first dot. Move my first dot right or left, wherever that needs to start. Okay, and then the last thing I look at is my amplitude. And again, that's how far above or below my midline I'm going to graph as I go. So handed an equation, kind of like I have over here on the whiteboard, you are going to be able to be asked to identify letters A, B, C, and D as you look at that equation. This sounds silly, but there are some times that you won't have all four of them, and we need to talk about, okay, then what is my answer if something is missing? Okay, so for example, if we were to look at this equation, and let's say I did not have a number right there, what would you tell me that A is? 1, right? There is another letter up there besides A that if it were also not there, you would also tell me 1. What's that other letter? B. Yeah, determining our period, okay? So if either of these two numbers were missing, when you are asked to fill in a chart that tells you what A, B, and C are, and D, and they don't have a number there, you would fill in the number 1, okay? But instead, what if I erased this guy? If D was missing, what would you tell me it is? 0. And the other letter, if it were missing and you were telling me it was 0, is? C, okay? Why the difference between saying 1 versus 0? It's what operation it is, right? If those two are missing, we would say 0. These two are multiplication, and when I'm missing something in multiplication, it's 1. Kind of like a nothing x is actually a 1x. These two are addition. If I don't want to add anything, I'm adding 0. Okay? So the difference, you do have to correctly fill those in. You can't just say like NA or doesn't have one or whatever. You give me either 1 or 0 based on which one it is. All right. The last thing we're going to do before we go back to our notes packet is on the other side of this, we are collecting all 6 of our perfect parent functions for sine, cosine, tangent, cotangent, secant, cosecant. We know 2 of those right now. So let's take a second and draw ourselves a perfect sine curve and a perfect cosine curve. with all the correct markings on our x and y axis so that we have all of our perfect parent functions gathered into one place. Now, if you are hesitant on how to correctly draw those perfect parent functions, I'm going to be talking through it up here. Otherwise, just go ahead and give me a nice picture of that. Here are your minimum required markings. Marking your fourth tick mark on the x-axis in your parent function, that's 2 pi. The second one would be half of that number, and your parent function is pi. In the negative direction, negative pi and negative 2 pi. You have to mark something along your y-axis. In our parent function, that would be 1. Yes?
So on the sign graph, is the first dot to the right of the origin always going to be above the midline?
Unless there's an ROX. Yes. Or a phase shift. But yes, our second dot that we draw when doing a sine curve will always go above. Unless we have an ROX, then it goes below. So first dot starts on the midline. In our parent function, that's at 0, 0. Then we would go over to pi over 2, up 1. At pi, we're back to 0. At 3 pi over 2, down to negative 1. And at 2 pi, back to 0. That is one complete sine curve, which we're going to come back to that later today, what one complete sine curve is. But we are expected to fill in always 2 periods, which would be one the other direction as well. Below, back to my midline, above, back to my midline. Always just fill in the whole graph. Anyone still need your perfect sine curve up there? Let's go do our cosine curve. Okay, cosine curve, same numbering on our axis. 2 pi, pi, up to 1, down to negative 1. That's your cosine curve. Parent function starts 1 above our midline, which in the parent function is at 0, 1. We'll then go to my midline, 1 below, to my midline, 1 above. Those 5 dots complete one cosine curve, which again we'll talk about later on today what one cosine curve looks like. But fill in all the way across, so now midline, below, midline, above. Any questions for me? Okay, then let's go back to our notes packet. What you guys are looking at up here is actually, as I think about like your quiz and test, kind of like 3 separate types of questions. You might be handed an equation and asked to identify A, B, C, and D. You might be handed an equation and asked to identify amplitude, period, phase shift, vertical shift, or you might just be handed an equation and told to graph it. Okay, so we're kind of looking at 3 different types of questions on this, but they're all related, so we think through all of this all the time anyway. So go ahead and fill in A, B, C, and D, and then we're going to talk about what extra notes we might make for ourselves on amplitude, period, phase shift, etc. No. That you'll do that when you get down here. You guys are going to be giving me answers from here on out, so if you want to be glancing at your table partner, checking things, especially like A on this one is a commonly missed problem, so maybe glancing and making sure you guys agree. Correct. You are correct. You're doing A, B, C, and D here. All right, Tanner, how about A? Ooh. Positive always. Remember our cheat sheet? Always positive, right? But that negative is going to have an impact when we get down to the graphing, right? Amplitude is a distance, so it has to be a positive number. But the negative is going to be in what when we actually graph it? ROX, right? It's going to be an ROX in our graph, okay? Sailor, how about B? Okay. Jonathan, how about C? Alex Downing, how about D? What's that? Well, I want 0. Yep, I want 0. These are your only options, 0 or 1 if it's missing, right? Okay, your job is always to be checking answers up there. Kenzie? Yeah, opposite. Opposite of what we see in our equation. That's a tough one. Very frequently confused. I will tell you, when we graph, we actually probably will graph easier if we look at here because we're so trained to think opposite here. But it's true. Your C value, your phase shift, opposite of the equation, just like your graph is opposite of the equation. Okay? Any others that we need to discuss? Okay. Now, moving below, I want you to take some good notes for yourself. One of the good notes is on A, that it's always positive. That's a good note to make, right? Especially if you made that mistake on this first round. Okay, moving to the below, I'm going to ask you which letter it's related to and if we need to actually change it or if it's the same number as what you see above. Okay? Jordan, let's start with amplitude. What letter, A, B, C, or D, is that related to? A. And Seth, is it the same or do we need to change it somehow? Amplitude. She said it's the same. She said it's related to A. Is it the same as A or do we need to change it somehow? It's the same. You are right. Okay? So that's something I would say. Amplitude equals A. They are the exact same letter. Okay? Sydney, period. Related to A, B, C, or D? B. Okay? Jude, the same as B, or do we need to change it somehow? Change it how? 2 pi divided by? Yeah. Always 2 pi divided by, right? So it's related to B, but by 2 pi divided by that number. So 2 pi divided by 2 pi. You got it, okay? LE period, A, B, C, or D? Related to A, B, C, or D? Did I say period? Can I change my question? Phase shift, A, B, C, or D? C. And is it the same, or do I need to change it? It's the same as C. Yep, opposite of our equation. It's the exact same as C, which was pi over 2. Okay? And our vertical shift. Gavin, what do you think? A, B, C, or D? And do I need to change it? No. So notice 3 of those are the exact same as the answers we just put above. So this is the one right here. Moving from B to period and period to B. That's the only one that's ever going to change. The others are exactly the same as the letter it's related to, right? We just got to remember that change. Okay, moving down into our graphing part of it. On your little cheat sheet, we talked about the order in which we want to attack our graphing. The first thing we need to do is just label our axis. Start with period. Is your 4th tick mark on your x-axis? Our period is pi. Label your 4th tick mark as pi. Figure out what half of pi is, which would be pi divided by 2, right? Okay. And then I want you to think combo of vertical shift and amplitude. Do I need to alter my normal 1, 2, 3 on my y-axis? No, it's fine. Okay. Then go back to our sheet. Okay, so we've numbered. And then the second step, it said to draw our midline, right? Does our midline move anywhere in this problem? No, that is D, which is vertical shift, does not move. Okay. After we draw our vertical shift, we decide on where to put our first dot based off of our C value, phase shift. Phase shift is pi over 2. And again, I kind of like looking back at the equation because we've been so trained to think opposite, right? So if it says minus pi over 2 in my equation, that actually means right, pi over 2. Ooh, this one's tricky because pi over 2 is normally here, but because of how we altered our graph, it's actually the second tick mark. So I need to move all the way to the second tick mark to put my first dot on sign, which is on the midline, right? Sign, first dot on midline. So this would be my first dot, which you do not have to label start or anything. You just put a dot there. Jordan. And there is an ROX. Now, for a sine curve, ROX doesn't impact us until dot 2. Because the first dot's on my midline, that's not going to change. But when I go to make that second dot, I guess I should say second dot, because normally I would go over 1, up 1, but because of the ROX, I'm going to go over 1, down 1, right? Got an ROX and an amplitude of 1. Okay. Fill in from there, back to my midline, going the other direction, alternate above, midline, below, midline, above, midline.
So where you started drawing with the blue period,
Oh, that's the same color. This would have been your, just showing you that it took the graph that would have been here and shifted it right pi over 2. Because otherwise it all starts to look the same and you kind of like lose where things are. I color coded. You do not have to. You can draw everything in pencil. You don't have to mark your starting dots, none of that. But for our notes, it's kind of sometimes nice to see the physical move to the right pi over 2. All right, we're going to do one more with our graph. So again, I'm going to give you a minute to think through A, B, C, and D. Do it. Yep. All right, let's get some answers up here. Cole, what's our A?
2.
Which gives us which below here?
Amplitude.
Amplitude. You are right. Good. Kaylin, how about B? And what did that tell you down here? Period. Yep. What did you put for your period? Good. Okay. How about Alex Roberts? C? And what did that fill in down here for us? Very good. Nick Peterson? D? Which is also? Okay. So then go to your cheat sheet. How do we attack our graphing? We start with our labeling, right? Brogan, what are we going to label our fourth tick mark on this one? 2 pi. You got it. Okay. So filling in from there, half of that would be pi, negative 2 pi. Okay. Labeling on my y-axis. Combo of A and D, or vertical shift in amplitude, right? If our graph is moved down 1 with an amplitude of 2, do I need to adjust the fact that we are going by ones? No. 3 will fit on there, or I should say negative 3 will fit on there. If you want to adjust, you can. You don't need to on this one. It'll fit by just numbering by ones. Okay. So go to our vertical shift. You should draw your midline down 1. Is the midline a requirement when we graph? No, it is not a requirement. We are usually way more successful if we graph that. So I would still encourage you to do that. Not a requirement. Okay. Alana, which direction are we going to move, right or left, to put our first dot? Left. Negative pi. So negative pi is going to be this line right here. I am doing a cosine curve, which means my dot is supposed to start above my midline. And my amplitude says 2, so that distance above my midline every time should be 2. This guy right here, up at negative 2, 1, or negative pi, 1, should be where you started this graph. Are we all good with that dot? Okay. Then we fill in our pattern. I am currently off my midline, so then I go to my midline, below, to my midline, above. I'm going to switch colors just to show you that our graph got moved left. You do not need to switch colors at this point. But that way you can totally see where my cosine curve was and moved. Now, here's the thing that's really frustrating and also kind of nice and saves some of us. Had I accidentally moved right instead of left pi, it'd be the exact same graph. Why does it work that way? Well, the distance you were doing your phase shift, right versus left, that is a distance of 2 pi, which is actually the same as the period of the graph. So if that were to ever happen again, you would get the exact same graph. So sometimes that'll happen. Will it always happen if I accidentally go right versus left? Not usually. Jordan.
So our amplitude was 2, but cos already starts 1 at like the midline, so wouldn't it be 3?
You don't add it on top of that. It is just literally the distance from the max to the midline, so we make that distance match your amplitude. So it's not a addition to where it already starts, but just stretching it to this number. Other questions? All right, shifting gears a little bit the other direction. Looking at a graph. So we're going to look at this two different ways. I'm going to give you two graphs, and then we're going to get 2 times where I give you words instead of graphs. Okay? And I get that it's a long day. Bear with me. But I've got one of each type here. One of a sine versus a cosine. On Friday, we are going to spend a lot more time getting in depth with how to write the equations of graphs. Today, I'm going to give you a super great tip on how to make this way easier because you're only going to write one equation. There are actually infinitely many correct answers to this, which we'll talk about Friday. Okay. So how do I make my decision on the very first question, sine versus cosine? Here's what I want you to look at, and write notes for yourself on what to look at because you're going to forget. To make the decision on this, you are going to look at your y-axis. If your graph is at the midline, at the y-axis, midline, you are going to pick to write this as a sine curve. If your graph is at a max or a min at the y-axis, you are going to pick to write this as a cosine curve. So let's look at our graph right here. As I trace up the y-axis and I finally find where I hit my graph, which is this dot right here, would you consider that a max, a min, or the midline of that graph? That's the midline, right? If I were to draw in the line that went through that dot, that's definitely the midline of our picture, isn't it? So because it's at the midline, we are going to pick to write this as a sine curve. Why am I picking that? Because if you pick that correctly, all of the ones that we will write until we get to Friday, your phase shift will be 0, which means we are starting our graph at the y-axis. Okay? So until Friday, your phase shift should be 0. Doesn't have to be, but it just makes it a lot easier. Okay? Amplitude. Find that midline for yourself. Find a max or a min and just count how far that is. Our midline happens to be at 0. Moving up to my maximum would be a distance of 4. So we would have an amplitude of 4. I'm going to talk about the vertical shift next because that's also the easier part. Where is your midline? 0, right? It is the location of the midline, is your vertical shift. The period is the most challenging part of all of this. And that is we have to understand what it takes to complete one curve. We are not the ones writing this. It is not the 4th tick mark because we didn't draw this picture. We have to go how they drew it. Okay? We are looking at a sine curve. We already decided that, yes? To complete one sine curve, your graph will start at the midline. It has to, at some point, hit a maximum, hit a minimum, and return to the midline to complete a sine curve. It doesn't have to go in that order, but it has to do those 2 things. Hit a max, it has to hit a min, and it has to get back to your midline. Once we have completed that process, you've finished a sine curve. So trace that. Starts at my midline, hits a max, hits a min, gets back to my midline. That is the end of one sine curve. Whatever number that stops at is the period. Pi, yes. So writing my equation, it is good to remember that the amplitude is the same as A. The phase shift is the same as C. The vertical shift is the same as D. The only one that we have to change is the period, right? Because that's not the number that goes in our equation. To find the number that goes in our equation, which is B, 2 pi divided by the period. 2 pi divided by pi is 2. That's the only one we have to change from the numbers we see in the equation. Writing our equation then. Amplitude is 4. We chose to write this as a sine curve. We are not going to have a phase shift yet. So on all of these pictures, we won't need double parentheses. We have a b value of 2. One thing I was noticing is some people were missing an x in their equations as I was writing or checking worksheets. Make sure you have an x. And then we don't have a vertical shift, so we will not add or subtract anything to that. You can put a parentheses around the 2x if you would like. It's not wrong. You don't have to have it. All right, let's try one more of these. Subtle difference in a cosine curve. Again, I am going to look at my y-axis to make my decision on this. If I trace up my y-axis, I hit my graph at a maximum. Because it is at a maximum, I would choose to write this equation as a cosine curve. The reason we are picking that is so that the phase shift is easy. I'm starting at the y-axis, which means we don't have a phase shift. So my phase shift will be 0 until Friday, if we pick strategically. My amplitude and my vertical shift, we need to find that midline. So count how far it is from top to bottom. Figure out half of that, or where the exact middle of that is located. Our lowest point is -4. Our highest point is 2. That distance would be 1, 2, 3, 4, 5, 6. So half of that would be 3. So 3 from the bottom or 3 from the top is where our midline would be located, which is also our vertical shift. The distance then from a max to that line or from a minimum to that line is our amplitude, 3. So this is what's different between last time and this time. We are writing this as a cosine curve. What does it take to complete a cosine curve? You start at a maximum or a minimum, you must return to that to complete the full thing. So if I start at a maximum, which we are on this one, you must hit the midline, hit the minimum, hit the midline, return to the maximum. So trace that. I'm at a maximum. I need to get back to a maximum to finish my cosine curve. Hit the minimum, get all the way back to a maximum. That happened at pi over 2. Period on this graph, pi over 2. All of these are exactly as is. That's A, that's C, that's D, except for the period has to change to be a b value, 2 pi divided by pi over 2. Remember, our algebra behind that is that I will multiply by the reciprocal. 2 pi divided by pi over 2 is the same thing as 2 pi times the reciprocal, 2 over pi. Pi's will cancel. Multiply straight across the top, straight across the bottom. We get a b value of 4. What's that?
It's a sine graph. How do we know if it's an ROX?
If it heads down from your first dot. Yep. Now, on that note, you guys will see one on your worksheet, and I bet you'll catch it, but if that had been a minimum instead of a maximum, wouldn't that just be a cosine curve with an ROX? That's when our cosine curve starts at a minimum. Okay. So putting all this into my equation, y equals my amplitude of 3. We already talked about writing this as a cosine curve. B value is 4, and our vertical shift is down 1. You cannot have the 1 in a parentheses. You can have a parentheses around the 4x if you would like it. Okay, the last little section, and I know it's a lot today, but that same idea, but without a picture to look at. Just told about what's going on in the picture. One thing I want to point out on this one is really nice to start with. It tells you the max, the min, and the midline, the period, and the phase shift. Of those top 3, this max, min, midline thing right here, you do not have to have all 3 of those. In fact, they typically give you 2 out of the 3. Here's my suggestion. Sometimes we get a little confused by that Draw yourself a picture of what's going on. It doesn't have to be a picture like adjusted for the period or the phase shift or any of that. But just draw yourself a picture that says, okay, I've got some curve that has a maximum up at 10, a minimum at 0, and a midline at 5. So it's going to be some curve that's got this midline running here, max happens there, minimum happens there, right? Does that make sense? Sometimes will help you think through then A, B, C, and D if you draw those things for yourself. Given that, I can see that my midline matches the D value. If they straight out tell you the midline, write that down as the D value. Then in my picture, I can see the distance between my max and my midline, or my min and my midline. If they didn't give me the midline, which they don't have to, it is the average of your max and min. So max plus min divided by 2. But if they give us the midline, it's just your distance from one of those max or min to your midline, which in this case is also 5, right? Distance from 10 to 5. B value related to the period, right? Period equal, or B equals 2 pi divided by the period. In this case, 2 pi divided by pi over 5. Multiply by the reciprocal. Pi's cancel. B value is 10. And then here's what we have to be cautious of. Guys, if they use the word left for a C value, what does that mean? Negative, right? And then my equation, it means plus. Again, the equation is the only time it's opposite. Now, on the last couple pages, we talked about deciding whether it was a sine or cosine curve. There's no decision in this one. I'm just following the format they gave me at the top that says sine. If you put cosine in there, guys, it doesn't really matter. What matters is that you were able to read those words and correctly identify A, B, C, and D and put them into the equation in the right places. A being 5, they said sine up here, so I'm just going to use sine. And this will be huge. On all of these, almost all of these, you will have both a B and a C. You have to have double parentheses. If you do not have double parentheses, it is not correct. So here, let me help you with the double parentheses. After the word sine, draw a parentheses. Put the number for B, draw another parentheses, then put your letter X. Opposite sign of C, so plus pi to indicate left pi. Close your double parentheses, put your vertical shift, plus 5. Questions on that? Okay, I'm going to talk through the last one very quickly, not give you a lot of time to think ahead of me because we are about out of time. But you'll notice the difference between what was given to us last time and what was given to us this time is they do not tell us the minimum value. They tell us the max, they tell us the midline. They only have to give us 2 out of the 3 of those. We can still figure everything out. And again, if you're having trouble, draw yourself a picture of what's going on, right? So as we start, it says max is 6, midline's 2, period pi, phase shift right, pi over 2. I don't know about my graph here. They say I've got a midline up at 2 and a maximum happening here at 6, right? So as I draw that, again, D is the midline, but the difference between 6 and my midline is a difference of 4. So your amplitude should be 4. The amplitude is frequently missed if you're not given both. So just be careful you pay attention to what's been given to you. B is related to the period, 2 pi divided by pi. Pi's cancel, B is 2. Phase shift right means positive for both phase shift and C, negative in my equation, opposite sign in the equation. Writing this out, amplitude of 4. I'm just writing sine because that's what they gave me. Double parentheses because we have a B and a C value. 2 parentheses x minus pi over 2 to indicate right, plus 2. They would tell you in words. Yeah. Any questions?